Hi class, with us running short on time, I realized that I talked about our new distribution, the distribution of sample means, but I forgot to share we have a new Z formula that goes with that. And so when we look at our estimate of standard deviation with distribution of standard means, that's that standard error, which is sigma, the population standard deviation over the square root of n. When we want to find Z for a distribution of sample means, we would be using this formula. This is slide 121 in your chapter 7 and 8 slide deck. So I wanted to take a couple moments to go over some of those slides to help you figure this out. And so, because you do have a couple problems that relate to this. So you would be given information about your population mean, you would be given your standard deviation, and you would be given your sample size. The mean for distribution of the means should be the same. So I had said that in an email earlier today, and that is the case. Your estimated mean is the mean of the distribution of the means should be the population mean, because when you're taking samples, a bunch of samples of that same population, those both should be the same. The variance for the distribution of means is going to go back to that idea of standard error, just like we had standard deviation and variance. And so then the standard error of the distribution of the means is our new formula. And I have those answers there. And so again, we're going to be focusing the most on this one, which is that distribution of standard error, which is the sigma over the square root of n. And so we had worked through that and shown that. I had shown that on the slide. I then had you have a couple problems in your homework set that go over finding Z. Finding Z for the distribution of sample means. How do you tell it's Z for that versus a Z for a population or a Z for a sample? Well, a Z for a distribution of sample means, in the information that's presented, you would be given a population mean, right? You would be given a sample mean. So that's the sample mean. It's not the distribution of the means mean, it's the sample mean. So when I took, so in this problem with the n, if I took a sample of n, 9 people, right, I took their average and I got an 84. I'm comparing that one sample to my population mean, right, which is the estimated mean for your distribution of means. And then I'm using my population standard deviation to estimate the standard error for the distribution of means. And so you would go through and you would do your M minus your mu, which is the top of the formula, all right, over your estimated standard error. That estimated standard error, you're going to have to do a little math. You're going to have to do your standard deviation over the square root of n, all right? So the first thing we would get is that bottom, the estimated standard error. So I would take my 12 over the square root of 9. Right, so that 12 over 3, all right, that equals 4. 4 is going to be the bottom of that formula. The top of my Z formula is then going to be the 84 minus the 80, which is 4, right? So then 4 over 4 is 1, right? So again, I'm just following some slides you have later in the slide deck. So I'm now on slide 126, all right? I do give several more examples of that for, again, first solving the estimated standard error and then getting to the Z-score. And again, the formula that you're going to use is this formula right here. And how will you tell it's asking? You will be given information about a sample size. You'll be given a sample mean. You'll be given a population mean. You'll be given the population standard deviation. When you see those things, you know that's a distribution of sample mean Z-score problem. A Z is a Z is a Z. So I then could ask about those, again, probabilities and using the Z-score calculator with these problems as well. All right, I hope this was helpful. Thanks.